Hi, and welcome to Trig Apps Day 5. Today we're talking about the ambiguous case. The ambiguous case tells us how many triangles that we can be formed. So we are finding the number of triangles that can be formed, and you need to draw a picture as accurately as possible. And we have a couple different scenarios. We have when we're using the ambiguous case, we're given certain conditions, and we have to determine by the conditions that are met how many triangles can be formed. We're given incomplete triangles, and we're either given acute angles, right angles, or obtuse angles. So we're going to start out with acute angles. If I have an acute angle and side A is less than B, okay, that's my first situation. And just for argument's sake, I'm going to give us some information that follows along with this. If the measure of angle A is equal to 30 degrees and side A is equal to 4 and side B is equal to 6. My situation is I have an acute angle and side A is less than side B. So let's draw a picture here. I'm actually not going to close my triangle. I'm not going to make a complete triangle because I don't know if it can actually happen. This is A, this is B. Side A is 4, side B is 6. And I need to know if this length of 4 is long enough that it will connect to my triangle and form an actual triangle. It will connect to the base. The only way I can know this is if I actually draw the height of my triangle and figure that out. Well, A is 30 degrees. Remember I said A was 30 degrees. So I need to figure out what my height is. So I'm going to look at this little triangle right here inside my triangle that's not really drawn. And I have an angle, the side opposite, and the hypotenuse, because that would also be a right angle. So that means I'm going to use the sine to find the height of the triangle. So this is my right triangle trig coming back into play. So it's the sine of 30 is equal to the height over the hypotenuse, which is 6. Well, if I cross multiply, I will get 6 sine 30 equals the height. The sine of 30 is 1/2, so 6 times 1/2 is equal to 3, which is the height. So that means the height is equal to 3. So the question I have is, if my height is equal to 3, can I form a triangle, or how many triangles can I form? In this case, I can form 2 triangles. I can form the triangle that I drew, where this is 30, this is 6, and this is 4, or I can have a triangle, this is an acute triangle, or I can actually have an obtuse triangle, where this is 30, this is 4, and this is 6. Because this is the obtuse angle here, it'd be across from the longest side there. So therefore, we have 2 triangles, acute triangle or an obtuse triangle can be formed. The next situation is still with an acute angle and side A is equal to side B. So I'm going to stick with the fact that I have an acute angle and the measure of angle A is 30 degrees. A is equal to 6 and B is equal to 6. Alright, I changed my pen color here too. Make it so, well, maybe you can't really tell the difference. Let's see here. There's my triangle, A and B. A is equal to 6, angle A is 30, and side B is 6. Now, can this triangle be formed? Well, if I have two sides that are congruent to each other, that means that this angle would also have to be 30. And just by doing the math, 30 plus 30 is 60. So I could have enough degrees left over to make a triangle. So therefore, I would make one triangle, and it would be isosceles. Okay? All right. Change my color again. I still have the acute angle. So, except side A is greater than side B. So the measure of angle A is still going to be 30 degrees. A is going to be 10, and B is going to be 6. So if I draw my triangle, this is A, this is B. A is 10, and B is 6, and this is 30. Is it possible to have a triangle where this side is 10 and this angle is 30, and B would have to be angle B would have to be less than 30 degrees because the side is 6 and the smallest angle is across from the shortest side. So that would mean that angle B would be less than 30, and I'd have enough degrees left over to make a full triangle, which only has 180 degrees. So yes, it is possible to have one triangle. All right, next one. I have a right triangle. All right, change our colors again. So, if I have a right triangle, and this needs to be, the hypotenuse needs to be the longest side. As long as that is the case with the information you're given, actually, let me, I just want to label my triangle because we've been using A as our main angle. So A is the right angle, and then this is B, and this is C. So here we would have one right triangle because A would be 90 degrees, as long as angles C and angles B are both acute. Okay. On the next page, we have obtuse triangles, or an obtuse angle. And side A is less than side B. So, I'll make up a situation. The measure of angle A is obtuse, so it's 150. And then A is 8, and B is 10. So A is an obtuse angle. Oh, that's not a good triangle. Try that one again. And then this is B. A is 8. B is 10. Is that possible to have a triangle that is like that? Well, no, because if this is 150 degrees, it should be across, because that has to be the largest angle in the triangle. That would have to be across from the longest side. The longest side is across from B, which would mean that B would have to be greater than 150 degrees, and in a triangle we only have 180 degrees, so there's no way I can have two obtuse angles in a triangle, so therefore this would be no triangles, because what I just said, the largest angle needs to be across from the longest side. If side A is equal to side B, okay, so I'll change colors again here. Let's do orange. The measure of angle A is equal to 150. A is 8 and B is 8. So this is A, this is B, this is 150, this is 8, and this is 8. Well, that would mean that angle B would have to be an isosceles triangle, and angle B would have to be equal to angle A. And again, you can't have two obtuse angles in a triangle, so 150 and 150 would be 300 degrees. We only need 180 degrees in our triangle, so therefore no triangles, because in an isosceles triangle, two angles must be congruent. Ooh, not writing good tonight. And you cannot have more than one obtuse angle. Okay. Changing again. That's good enough. Oops. If the measure of angle A is 150 and A is 8 and B is 6, is this possible? Oops, my bad. I labeled backwards. A is 8, B is 6. Is that possible? Yes, this is possible because it's obtuse triangle. Angle, right from what we see, 8 is the longest side. It's across from the largest angle because the obtuse angle has to be the largest angle. So that means the angle B just has to be less than 150. So it can possibly work out that that would be the case. So, in summary, if we have an acute angle and A is less than B, we use our sine ratio. Okay, and when we're using our sine ratio, if A is greater than the height, we have two triangles. Okay, and something I didn't tell you in the front is the two angles will be supplementary. in the acute and obtuse triangle. And I'll show you what I mean in a second. If we go back to our first example, this angle here that I have drawn, my obtuse angle, and this angle here that I have drawn will be supplementary. Angle B, my two angle B's will end up being supplementary. That's what that means. Okay. That's one condition. If A equals the height, we have one right triangle. If A is less than the height, we have no triangles. And I'm going to show you an example of that in class. It's kind of a visual thing that you need to watch and see. If A equals B, going back to our acute angle, if A equals B, we have one triangle. And if A is greater than B, we have one triangle. So we can either have one, two, or no triangles for acute angle, and depending on our given situations. If we have a right angle and A is greater than B, we have one right triangle. To the obtuse, if A is less than B, we have no triangles. If A is equal to B, still no triangles, because we don't have enough degrees left over. And if A is greater than B, we have one triangle. All right, I know that was a little lengthy and it can be a little bit confusing, but we'll go over this again in class and I'll give you more explanations. And like I said, I've got some visuals for you to look at while we talk about it. So good luck.